right now, the FAA requires you to know the actual tip path travel for the propeller. If they are too far out of range when they are passing the same point in rotation, it's going to cause high vibration. That causes more wear and tear on your engine mounting links. That causes more wear and tear on your crankshaft and all the subsequential hardware. So what we need to ensure is that these tips of the blades are passing past a congruent point. And how we do that is called blade tracking. So we will designate one end of the propeller blade as blade A. And we have to block something up with a markable piece of paper that we can align the propeller blade directly above that. All we need to do is have a scribe or a marker or a pen, and we need to use the blade as a traced template to give us a marker. And I'm going to label that as blade A so I can compare the two. Now all I need to do is keep this blocked up stationary and rotate the propeller through its progression. As I do that, I bring now my blade B down to the paper, and I use that same angle to mark my paper with, and now I'm going to label that as blade B. It's good to mark and label which blade strike is which, just in case you have more than two blades. And now all I need to do is I need to use a steel scale or a ruler in this case, and I need to measure the distance between these two lines. What that is telling me is this: if I measure from the difference between this line and this line, right now I get I get 3/8 of an inch. For this, on this propeller, on this engine, on this aircraft, in the maintenance manual or in the service manual, there will be specifications of how much difference between the tip paths can be. So you must reference the maintenance manual or the manufacturer's manual. Now, once you have this dimension, you will know if your propeller is within or outside of its limits, and that is where you do your corrective action.